Hey guys, welcome back. So we left off before the break talking about those mother functions. Don't forget about them, they're not going anywhere. We're just going to focus in on the quadratic mother function this week. So we're going to look at the standard form of quadratic. That's ax squared plus bx plus c equals 0. Now, if we're in this form, we can't exactly transform the mother function because we don't see the shifts or the stretches or anything. It's all multiplied out and simplified, so we can't see what's going on. So the first thing we need to do is find out where our butt is. The vertex is what it's called. So we got to find that vertex, that bottom or the top point, if it's upside down. And then we're going to use our odds to graph them. Remember, a times the odds is how much we go up from the butt. So, there's Desmos, graphing calculator, of course, you could use that. But I will require you to show your work. So you will need to show me how you got your vertex. Here's the formula, negative b over 2a. That's what you need to remember. Remember, it's ax squared plus bx plus c equals 0, or f of x equals that. B is the coefficient of x. So you do negative b, so let's do that. Negative b over 2 times a. A in this case is 1, so that's 2 times 1. Easy enough, negative 2 over 2, that's negative 1. This piece looks complicated, but it's really not. That just says plug in what you just got into your function. Let me grab my calculator. Give me a second. All right, so we're just going to take this function and plug negative 1 into it. So make sure mode 1, make sure you use parentheses whenever you're evaluating stuff. Anytime you got an x, place with some parentheses and stick negative 1 up in there. Boom, negative 6. So in this case, our vertex is negative 1, negative 6. So that'll be down here somewhere. More like down here somewhere. You don't have a scale on the graph, but it's going to be close to this y-axis. And then we just make the parabola shape. We know it's going to be opening up because that's a positive a. A is positive, opens up. Let's just see exactly what it looks like. There it is. So here's our butt, negative 1, negative 6. That's the vertex. From there, a is 1, so you should go right 1, up 1. So 0, 5, negative 5, yeah, or negative 2, 5 should be there. Looks about right. That's if you're using your odds. This is the general shape of this parabola right here. So just sketch it. There's no grid or anything. You don't have to be perfect on this one. We're just trying to get the shape to notice that the difference between these two is when a is positive, it's going to open up. If a is negative, it's going to open down. Let's look at that. So use Desmos. Negative x. To get a squared, you can do shift 6. Or you can just hit this up arrow and have all your functionality down here. Yes, it does have inequality symbols on there. Plus 3x plus 7. And here's this one. Now, I can't see the vertex, so I'm going to zoom out a little bit. There it is. And if you hover over it, it gives you this decimal. Obviously, you can't give me a decimal. I don't want decimals. Decimals are not acceptable. So you have to convert that to a fraction one way or another. Now, if you have this calculator, a little handy shortcut you can do is mode 5, 3. Negative 1, 3, 7. And it'll give you these random things here. Those are your x-intercepts, actually. That's the solution. So this thing was equal to 0. And it tells you your x value is 3 halves, and it's a maximum. So we're going to get to what that means in a second. So 3/2 and 37/4. Of course, you could have gotten that the same way. Just do -3 over 2 times -1. The negatives cancel. You get 3/2. And let's see what it looks like. The vertex is up here somewhere. And it does something like this. So there's a sketch of that parabola. Remember, the graph of a quadratic is called a parabola. That's the name of this type of graph. The function is a quadratic. The graph is a parabola. If the a is positive, it's going to open up. If a is negative, it's going to open down. Now, I'm not going to make you graph the intercepts. Sometimes they'll be easy. Sometimes it won't. For now, I won't make you graph them, but I do want to talk about them. There. So if you're looking for your y-intercept, all you have to do is plug in 0 for x. So if I were to plug in 0 here, everything but the 7 would cancel. I'd have 7. My y-intercept should be 7. There it is. Now for the x-intercept, you need to use the quadratic formula, which you should be familiar with from Algebra 1. And we also did it in geometry a little bit, not much. But there's the formula. There's the results. And of course, I'm not going to make you graph these. We're not going to worry too much about the intercepts right now, but we will. You will need to be able to use this formula. You will have to be able to give me these exact values here. Okay, but again, we're going to come back to the intercepts, but that's what these little dots are. Those are your intercepts. It'll give you your vertex and your intercepts. So don't feel like you have to plot those just because they're on Desmos. You don't. Now, if we were to imagine a vertical line going through this thing at, let's say, x equals 3/2, you can see it splits it in half. It's an axis of symmetry, that's what it's called. If we were to reflect the parabola over this line, x equals 3/2 in this case, then it would land on top of itself. The formula for it is just x equals the x coordinate of your vertex. That's how I knew what that was, because I knew, oh, hey, this has vertex at 3/2. So x equals 3/2 is my axis of symmetry. Now, where it changes from increasing to decreasing or decreasing to increasing, that's called a turning point. And we call that turning point, in the parabola's case, a vertex. So this is my vertex right here. If it's the lowest point of the graph, it's a minimum. If it's the highest point, it's called a maximum. So notice that there's no point above our vertex here. So this would be a maximum. So let's go ahead and label these. So this is a minimum. And over here, we have a maximum. If we were to draw some vertical lines, there's not much room on your paper, don't worry about it. Make some notes on the side of what these things are so you know what we're talking about. But if you don't have room to put them, don't worry about it. These are our axis. This is our axis of symmetry. There you go. All right, so let's just practice. Does it have a min? Does it have a max? What's the axis of symmetry? What's the vertex? So again, we're going to use this formula right here to calculate our vertex. If you have this calculator, you can type it in and it'll give it to you. But I want to see you show me negative b over 2a. Just show me that and we're good. So what's my b here? 0. So it's negative 0 over 2 times 4, which is obviously 0. If I plug in 0, I get 0 back. That's 0, 0 for this one. This is positive. It's going to be opening up. It's going to look like this. That's going to have a minimum value. The axis of symmetry, that's x equals, what's this number here? 0. All right, look at this next one. Here we have a b value of 6. This means negative 6 over 2a is negative 1. That's negative over negative is positive. 6 over 2 is 3. I got 3. I need to plug that in. That's going to be negative 9 plus 18, so that's going to be 9. Calculator, you could type it in here or just plug it in. Negative parentheses 3 squared plus 6 times 3, 9. This is negative. That means it's opening down. It's going to look something like this. This is symmetry. X equals, what is it equal? 3. Over here, not very interesting. Our b is 0. Doesn't matter what c is. Doesn't matter what a is. B is 0. Our x coordinate is going to be 0. Plug that in. 0 here. 0 plus 7 is 7. That's negative. That means we have a maximum value here. And x equals 0. On this one, we got everything. So negative 8 over 2 times 1. That's positive 8 over 2 is 4. Plug it in however you want to. 16 minus 32 is negative 16 plus 9 is negative 7. Double check that. Plug in 4 minus 8 times 4 plus 9 is negative 7. Positive, so we have a minimum value there. Axis of symmetry, x equals 4. There we go. So now, let's put all that together and graph it. The first thing, find your vertex. Can't do anything until you calculate your vertex on these. So you could go to mode 5.3, type it in. Don't worry about your x-intercepts. They don't matter for now. But this does matter. Oh, look, it tells you it's a max and min here also. So we'll give you that. 3, 2. So my vertex is going to be 3, 2. But again, I need you to show me. Negative 6, well, negative 6 over 2 times 1. That's 3. And then I can assume you can plug it in yourself. Just show me that and we're good. So the way I like to graph a quadratic is by plotting the vertex, 3, 2, and then using my odds. Remember, a times your odds is how much you go up or down. So a is 1, my odds are 1, 3, 5, 7, etc., etc., etc. If you multiply all those by 1, we're going to get back 1, 3, 5, and 7, etc. So I'm going to go right 1 and up this 1. Left 1, up that 1. From here, I'm going to go right 1 more. This time I'm going to go up 3. From here, I'm going to go left 1 more, up 3. If I had space, I'd go left another one, up 5, right another one, up 5, 7, etc., etc. But we don't have space, so that's it. Then we're just gonna sketch this thing. Make sure you have a nice smooth bottom there. Okay. So on Cami, we have to do the same thing. There's no quadratic graphing button. Like you have a line tool, there's no quadratic tool. So it has this chart. Don't worry about it. Actually, I think I'm going to delete that chart so you have space. As I'm going to move. I have to put this in Google Classroom yet. So I'll delete the chart before I do that. Burning. Let me zoom in a little bit. And no, that's good. So start with our vertex. 3, 2, 1, 1, 1, 1, 3, 1, 3. Sketch it. Oops. And there we go. You can come back and fix that a little bit. It's good enough for me. Now I have my thickness on 1. Probably want to keep it small for these. The next question asks about the domain and the range. Well, it's a polynomial mother function. You know the domain of the quadratic is always all real numbers. That's no question. And the range is based entirely on the base. In this case, it's a minimum at 2. So we do include it. We go 2 to infinity. And let's look at number 7. Again, this is going to be gone, so I'll do something like this. So you have space to work. There's no reason for you to point plot. Don't do it. So if I'm doing this, I find my vertex. So negative, negative 8 over 2 times 2. Positive 8 over 4 is 2. So my vertex would be 2, and plug it in. That's 4 times 2 is 8. That's negative 8 plus 2 is negative 2. So if you want to, 2, 8, 6, 2, and negative 2. Remember, we don't care about the intercepts, just the x and y, minimum or maximum values, whatever it may be for a vertex. 2, negative 2 is right here. A in this case is 2, so I'm going to do 1, 3, 5 times 2. 2, 6, and 10. Go right 1, and it is positive, so if it wasn't positive, I'd take care of that right here. Right 1 up 2. Right 1 up 2. From my new data, go right 1 up 6. 3, 6. Left 1 up 6. There we go. So I'm going to try and, there we go. Didn't mess up too terribly. Yep. And don't try and be perfect. It's not easy to do. So just, that's good enough. Make sure your bottom's round. That's all I ask. Make sure your bottom's round and tries the 3 points. Don't do something like that. That'd be terrible. Fix that. And we can talk about the domain of the range. Not going to write it down. Domain, all real numbers. Done. So range is going to be whatever this is going to be either our starting or ending point. It's opening up. That's where we start. -2 to infinity. Let's look at number 9. Okay. The formula for vertex, negative, b is -1 in this case, over 2 times a is -1/2. Oh no, it's a fraction. Who cares? Type in the calculator if you need to. That's basically 3 negatives, so that makes a -1. Type in the calculator if you don't believe it. From there, that's going to be a fraction of 1/2. -1, 1/2. Check the calculator. If you type this one in, it'd be -1/2. -1 and 0. Don't forget that 0. 1/2. There we go. So -1/2 is about right here. So in this case, you will have to use some fractions for your vertex. Then we're going to do our odds. So 1, 3, 5. In this case, a is -1/2. We are multiplying here, so don't think we're subtracting, just as negative. It's going to be -1/2. That means we're going down. -3/2. 5/2. Go right 1, down 1/2. 1, down 1/2. So now that turns into a nice number. 3/2, that's 1.5. So 1.5. There's half, about right there. 5/2, that's 2.5. So there's a half and 2 more. Okay. Half and 2 more. Right there. So we could probably even do 7. That's 20 dots for me, but let's just see if we can get 7 on that. That's -7. 3.5. 3.5 right there. 3.5 right there. There we go. Domain, all the numbers, range, -infinity, all the way up to +1/2. Notice we have a maximum point here, so we're starting at -infinity. We're going to end at this guy right here. We're always going to include that. Piecewise, goes back. Don't forget to calculate your endpoints. So I'm going to do this one on here because I have a bigger graph. First thing, find your endpoints. Plug in the -4. Whether or not it includes it. So 2 times -4 plus 5. -8 plus 5 is -3. We do not include that point, so I'm going to plot -4, -3 with an open circle. Next, you could either plug in a number to the left, so you could plug in -5, which you get there. Or you just use your slope since this is a line. It's 2, so that's 2 over 1. So you go down 2, left 1. And let's see. -10 plus 5 is -5. Go down 2, left 1. Or you could plot -5, -5. Same thing either way. But you do need to recognize this mother function as a line so you know how to draw it. Like that. Again, make sure that's open. Make sure it's noticeably open. Arrows, not too worried about, but might as well put them on there. Zero red one, I guess I'm gonna do it in blue. So plug in your endpoint. It's a quadratic, even if it's a cubic, even if it's absolute value, it doesn't matter what it is. Plug in your endpoint. That's 16 minus 12 is 4. So -4 I plug in, 4. This one does include, so I'm going to make a solid dot, which is mostly solid. After that, you must find your vertex. You got to. No exceptions. You need the vertex so you know where to go up and change your increasing and decreasing, where your turning point is. So -3 over 2 times 1, that's -3 halves. Plug that in. Yeah, I'm going to use a calculator. Oops. I did that. 1, 3, 0, -3, and -9, 4. Nine fourths, that's 2 and a fourth. For me. Yeah, that's good. Maybe this. That might work. It's going on forever there. And it's stopping right there. Okay. So make sure you make your vertex noticeable. Doesn't have to be in perfect spot, just make it noticeable. That way I can see, okay, you know what you're doing. So that's the piecewise function of the parabola. Domain, nothing's excluded, so that's all the numbers. Range, it's from negative this y coordinate of our vertex. Because this part keeps going on forever and ever and ever. Okay, so piecewise, that's coming back. It's not going anywhere. Don't forget about it. And so are inequalities. So here we go. Quadratic inequality. Exact same thing we've been doing. You graph the quadratic, and then guess what? You test the point to see where you shake. Negative b over 2a. That's negative 1. Plug that in. 1 minus 2 minus 2. That's negative 3. Opening up. Let me do this on camera so you can see. Again, don't worry about making a table of values. That's just a waste of time. We have a vertex of negative 1, negative 3. Before I continue. Two, negative 1, negative 3. Okay. The product. Gotta be dotted. So you could try and do this sort of thing to it. I'm not gonna, I'd rather just graph the thing. Terribly like that. And I'm gonna come back. I'm just gonna make it dotted. So whatever's better for you. Doesn't matter to me. That's how I'm gonna do it. Now we need to test where to shade. So we're either gonna shade inside the parabola or outside of the parabola. So I'm gonna test 0, 0, it's my favorite. 0, is that greater than negative 2? Yes, it is. So I plugged in 0, 0, just like we did before with inequalities. I tested this point right here. 0, 0, that's really big. 0 on the left, negative 2 on the right if I plug in 0. It works. That's what we're going to shade. We're going to change the transparency though. And that might be a little too thick. Let me start with 8. So we got to follow the parabola. It doesn't have to be perfect, but try not to go outside of it. And again, you're either going to be inside or outside of the parabola. There it is. And, well, I guess we're not going to worry about domain range. Why not? Domains. Well, what is the domain? Or we can plug in whatever the heck we want. Don't know about a real number. Now the range, on the other hand, it's going to be this, -3 to infinity. However, it's a dotted line, right? So our range is going to be -3 to infinity. Cannot include that -3 in this case because it's dotted. That's the only difference on the inequalities. If your range, which they don't ask for the boundary range on these, but if you're looking at your range, make sure you don't include your minimum maximum value because it's on a dotted line. Unless, of course, you have something that includes it. Just watch for the dotted line. Okay, so we're going to do 2 and 4. I'll do it over here for you. And I'm going to remember to hide these things. All right, first thing, find your vertex. Negative b over 2a. That's positive. 4 over 2 is 2. Plug it in. That's 8. That's -4. So that's 4 minus 1 is 3. Use a capital. 2, 3. Okay. -1 is our a. So 1, 3, 5. And I multiply those by -1, I'm going to get negatives. So I'm just do that. All I gotta do is count. There we go. It's solid, so I don't have to worry about making it dotted. Test the point. 0, 0 is on the outside. Let's see if it works. Is 0 less than -1? No, it is not. So I'm not going to shade outside. I'm going to shade inside. Putting together everything we've already learned. Nothing really new except calculating the vertex of parabola. That's the only thing that's kind of new. But you should have done that in Algebra 1 anyway. Did you? Don't know. Don't care. A few more, and then we're going to call it a day on here. Change the transparency of that. All right, so let's see. Well, b is 0 in this case, so I'm not even going to worry about writing it all out. It's going to be 0. To get the plug in 0, I get 6. 0, 6 is right here. Okay, a is 1, so that's just 1, 3, and 5. Okay, so I can do this, but I can't do anything else, so that's all I'm going to have here. So let me graph this, I guess. Okay, now it needs to be dotted, so I'm going to go back and make it dotted. Test the point. I like testing 0, 0. In this case, 0 is less than 6, so it works. So I'm going to shade outside of the parabola this time. It's all this stuff out here. So first I'm going to nice and easy trace around the parabola. And I'm going to get all this, everything else. Now the book we use says based on the direction you can shade below or above the line. I just don't like that because it only works if you're written exactly in this way. If it, for some reason you have f of x on the right side of your inequality, it's not going to work. Let's just be safe and test a point because that will always work. There. That's the answer to this graph. Graph? Equation? Inequality. There we go. That's the answer to this inequality. All this yellow. And again, the range is not going to include the 6, so it would be 6 to infinity. Parentheses. 6 is also what I'm looking at. Yeah. Every time. There we go. Okay, let's look at this one. So negative b over 2a. So that's 4. I'm just going to plug that in the calculator. So I'm like calculating it. Negative 4, 12. Who cares? 4 is our main value. Vertex. Plot it. 4 and 4. 1, 3, 5, but I have to divide those by 2, so that's going to be a half, 3 halves, and 5 halves. Right one, up a half. Right one more, 1 and a half. There's a nice point. Figure that. And I don't have space for the next one. It'll be up here. But I'm not going to worry about it. It's off the graph, off the grid. Again, it's going to need to be dotted, but I like to do that after I draw it. And there we go, I have a nice dotted line. Test the point. 0 is not bigger than 12, so I'm going to shade inside since 0, 0 is outside. So I'm get it close to the line without going over. If you go over a little bit, it's fine. But again, make sure your transparency is down so I can still see your line. If I can't see your line, this time I'm going to take off points. Here's what some of y'all did on that last test. Now, how am I supposed to do that? Turn your transparency down, people. All right, guys, that's it. That is all we're talking about today. That's the end. Done. See you next time. Goodbye.